Okay, so we have these events. Then let's say this event has its own thingy, and then number 2 we have event B. Event B has its own thingy also. That is event B. It has its own thingy. Then now let's talk about this. This has bring its own thingies, and this has bring its own thingies. Hence, they are what? They are united. We call them what? Union. Okay? They are union. A union was represented by a shape like this. That was union, okay? But now we represent it as what? As or. Okay? And or goes hand in hand with addition. Okay, now come with me. It says what? It says that the rule here will say the probability of A or B is equals to the probability of A plus the probability of B minus the probability of A and B. Okay, this rule is called a universal rule. Why is it called a universal? The reason it's called a universal is because it is used whenever you have a problem of probability and you have all other, you don't know what to do next, okay? So this is a probability. Then this one is called what? Is called an independent rule, okay? Whenever they speak about independent, they speak about this one, okay? That is grade 11. Whenever they speak about this one, they speak about a universal rule, okay? Now let's try and continue a bit, okay? Those events are true and we call them inclusive events. Now we can have what we call an exclusive event. Come with me. An exclusive events. Now, come with me. Whenever we say these are inclusive, they are inclusive of what? Of intersection. These ones have no intersection. You will see. Whenever I draw the first one, this is the first one, okay? It has A and it has what? B. So we have A and we have what? B. Let's talk about this one. This one, whenever it's like this, is called mutual. It is mutual. It is close by. So hence, that's why whenever they say prove that it's mutually exclusive, we are going to speak about this one, okay? These are mutually exclusive. Why are they mutually exclusive? Number one, there is no intersection. There is no intersection at all. If there is no intersection, it means that the probability of A and B is impossible. You know the word impossible, 0, impossible, remember? Yes. Okay? Now, make sure if you are watching this, go back to watch the first video. You will see what I'm talking about, okay? Now, if so, that means A and B cannot or can at the same time. They cannot occur at the same time. Okay? Hence, they are called mutually exclusive. That is event number 1 under mutual exclusive events. Number 2, we have this one. We have A and then we have B. This is A and this is what? B. Okay? Now, this one says it's either you are here or you are here. Hence, it's called what? It's called an exhaustive events. Okay? An exhaustive events. Why do we call it an exhaustive events? It's either you are this side or you are this side. It means hence the probability of A or B should always be certain. Okay, the probability of A or B should always be certain. Okay, now let's utilize this formula to make this true. Okay, come with me. I'll have probability of A or B is equals to probability of A plus probability of B minus probability of A and B. Okay, we know this to be 1 according to this one. We haven't talked about this one, and then we haven't talked about this one, but we know that this is 0. Why? There is no intersection. Hence, the probability of A plus the probability of B will always be equals to 1 according to exhaustive events. So here we can say this probability of A plus the probability of B is equals to 1. Okay, I know you see how I have proven this one from this. Okay, now come with me. Hence, if it's so, that means exhaustive give birth to what we call complementary events. Come with me. Now, what do we know about complementary events? They must be exhaustive and mutually exclusive. Okay? If so, it means what? It means the probability of not A should be the probability of what? Of B. And the probability of not B should be the probability of A. What does this mean? If you are not in A, you are in B. This is one. Okay? If you are not in B, you are in A. That is the second one. Okay? Now come with me. Then let's use this formula to substitute what we have here. Okay? So number 1, you will have the probability of A plus, instead of B, I will insert this one. Probability of not A is equals to 1. Then take this to the other side. So the probability of not A is equals to 1 minus the probability of A. Okay? Now let's choose the second one. Okay? So that's the first one. Okay? The second one, we say the probability of the probability of not B plus the probability of B will be 1. Okay? If it's so, let's take now this one to the other side. So the probability of B will be equals to 1 minus the probability of not B. That is what we know. So most of the people, they know it from here. They know it from here. But we know that this came from this one. Hence, there are notation they will use for not. When they say the probability of A, then there is a prime. This means not. Then this is equals to the probability of A, then there's a prime outside, which this is equals to the probability of not A. Okay? And then this is also equals to the probability of A, and then there's a slash up there. This is not, this is not, this is not, and this is not. That is how we identify the nots. Okay? Now, let's continue to explore the Venn diagram of this. Okay?